All right, this is a lesson on accumulation functions, and we're not doing this entire lesson, so this video will be the part of this that we will do. And so we've talked about this some, but this is a little bit more of a stronger way to show how we can use integration to talk about accumulating stuff. So if we have and again, some of this we've already talked about. So we know that if you take the integral from a to b of f of t dt, then we're going to call that capital F of x. So that's going to be the area under the curve. Now remember, it's only area under the curve if it's all above the x-axis, okay? So if we have any value of x anywhere in between a and b, and we integrate from a to x, okay, which is what we, here we have a to b, but, or I should say a to x, sorry, so that should be an x, maybe it's right on your paper, but it's not right on here. So this is an accumulation, so from a to x, then that would give us the value of f of x, okay? So anytime we take a portion or we go in between this interval a to b and we integrate from a to x, we're going to call that the function capital F of x. That's the antiderivative. Now, the important part of this theorem, we're going to go through some examples, the parts that we need to, that will be on many, definitely on free response questions. Has to do with this fundamental theorem of calculus part 1. So if our function's continuous on the interval a to b, then g of x, if g of x is defined to be the integral from a to x of f of t dt, don't get concerned about t's versus x's. We just can't use the same letter, or we can, but it'd be confusing. So the t is just there to be different than the x. You're still going to end up with it being an x. So if f of x is continuous, then this g of x that's defined to be the integral a to x is also continuous and differentiable. And what's really important is that if you take the derivative of g, you're going to get f of x, okay? So that's this theorem right here. Now the thing to be careful about is it's only true that the derivative of the integral equals just the function with the x plugged in if this bottom is a constant and the top is just plain x. Okay? So if you take the derivative of an integral from a constant to x, you just get the function with the x plugged in. Okay? So, because we know derivatives and integration, you know, are kind of inverse functions, but we have to be a little careful, and we'll see that later about if the top is not an x, okay? All right, so here's where this is going to come up, definitely on the AP test. So we have a graph of f, okay? So this function is a graph of f. This is important. So this graph is f. We're going to define g of x to equal the integral from -6 to x of f of t dt. Then we want to find some values here. So we want to figure out what is g of -3. Well, we need to figure out what does g of -3 mean. Well, the definition of g of x, it's the integral from -6 to x. Well, my x is -3 of f of t dt. That means I want to find the area under the curve, because this is above, from -6 to -3. So this first one is to find this right here. Okay, and remember, we don't draw really difficult and hard when we shade it. I'm going to actually erase it because I can't really draw lightly with the pens, but you can just very lightly shade that. So if I want g of -3, I simply want this area of this, and I'm going to split it this way because that gives me two different trapezoids, and so I can find those areas. Now, another way to do, for example, this first one is to recognize you have 3 whole squares, and then you have 2 that are exactly a half. So that's going to make that one 4. So certainly use that. Now be careful on the next one because you don't have 2½ squares. You have a slant there that's not splitting that diagonally, okay? So I could do 2½. I could just do trapezoid rule. It's 1/2 the height, which is 1, times base 1 plus base 2. Well, base 1 is 3. Base 2 is, I guess we'll have to call it 2.5. So 3 plus 2.5 is 5.5. And then you have divided by 2 times 1, because the height was 1. So we should just get 2.75. And so my answer is 6.75, okay, when I add those together. G of 0. So again, G of 0. Definition of G is that it is the integral from -6 to x. These are the same thing. So G of 0 would be integrating -6 to 0 of f of t dt. Now, something to keep in mind, we've already figured out the area from -6 to -3. And we already know that's 6.75. So we only need to find this additional area right here in order to get our answer, okay? Because it's accumulating, okay? It's accumulating when we go through that. So we're going to, again, assume that this point right here was at -3, 2.5, okay? Because it looks like it's about half there. So our area of this trapezoid in the blue trapezoid is going to be 1/2 the height, which is 3. So 3/2 times base 1 plus base 2. Well, it's 1 plus 2.5. So we're going to have 1/2. So we have 6.75 from the previous answer, because that's adding -3 to 0, and then do your arithmetic. You're going to get 5.25 for the blue area. Add that together and you're going to get 12. Okay, let's do G of 4. Well, again, to do G of 4 means I want to add all the way from -6 to 4. Well, I've already done part of it. I've got the red and the blue I've already added, so I just have to add the green part. So that part again would be 1/2 height, which is 4, times base 1 plus base 2, which would be 1 plus 5. So that's going to be 6 times 2, which is 12. So G of 4 is going to be the previous answer of 12 from here, because that was all the way up to 0, plus the new answer of 12, so my answer is 24. If I want to do G of 7, again, the technically, G of 7 means that we're going to integrate from -6 to 7 of f of t dt. Well, again, I already know that all the way up to 4, I already know that that answer is 24, so I only need this remaining portion added to that 24, and that's how it's accumulating, okay? So I have, again, I have a trapezoid, so I have 1/2 of height, which is 3, times base 1 plus base 2, which is 4, plus 1 again. So I'm going to have 15 halves, or 7.5, and I have to add that to, well, let's see, 4, 5. So that's 3. It's 3 for the height. 1/2 times 3, base 1. Oh, that's a 5. Sorry, that was a 5, not 4. So 5 plus 1. So that's going to be 9. So you're going to have 24 from the previous problem plus 9, which is 33. Okay, so that's how you can answer these questions and work through that. Okay, So we're going to do this next example, which this is a very common question to kind of look like this. What would normally happen is you would have a table that you needed to find some values, and then this is you doing this kind of off to the side. You need to think about what would I have there, okay? So if my input is 0, g of 0, remember here's your equation, would be integrating from 0 to 0, as you can see written here. If I'm integrating from 0 to 0, I know I'm going to get 0. That's an easy one. I don't have to work very hard at that one because that's a property. The next one is g of 1, and we're going to integrate from 0 to 1. Well, this is an easy one because my squares are 1 by 1, so I just get 2 for that one. I don't have to work too hard at it because I can see there's just 2 squares there that are the same, and they have an area of 1. Then if I knew the next one, I need g of 2. So g of 2 would be to integrate from 0 to 2 of f of t dt. Well, I already have the answer from 0 to 1, so I only need to add to that the area from 1 to 2, which you should be able to easily see that that one is 3. If you need help with that, that's another thing to work on, and that one was 2, so you can work on that. So I'm going to have the previous 2 plus the 3 I just added is 5. If I want to do do 3, it means g of 3, which means integral 0 to 3 of f of t dt, which means, again, I just need to add one more portion, and this is just a triangle here. If I do this portion, this is just a triangle. So I'm going to have 1/2 base times height. Height is 4. So half of that is 2 times 1, so I get 2. Now I'm going to add that to the previous 5 because I already know this part here is 5. Now add 2 to that, I get 7. Now let's look at g of 6. So we're skipping a little bit, not doing every one of these, okay? G of 6 is going to be integrate from 0 to 6 of f of t dt. So to go from 0 to 6, that means I want this area. Now, the thing we have to be careful about is we know the area of that upper part, but we have to remember that all of this is below, going over here to 6, this is below the x-axis, so we have to make that negative. So if we find this area, pretty simple. Again, you could just add stuff up and look. You can see that you have 3 squares here, and then you have 2 that are exactly halves. That line goes through the diagonals. So you're going to have 4. So this is going to be 4. However, it is underneath. So we do need to remember that it is negative 4. So that means you're going to have the previous answer of 7, because that was all the way up to 3. That was our positive answer. And then you're going to subtract 4. So my answer here will be 3, because it's 7 minus 4. And then if I want to do g of 7, well, I know that the previous answer is 3, and I just need to add this part, which is negative, and that part is going to be, that little section has an area of 1. You can do 1/2 base times height for the triangle, and you'll see the area is 1, so I add it to the previous. Oh, actually, I have to subtract it, because the previous answer was 3, this is negative, so I have to subtract it, so I get 2. Okay, so this is a pretty important concept because it comes up a lot on the AP test where you have to use this idea. This is actually the really important part here, is how we would determine this, because this is going to come up and for sure be asked, and you need to understand the relationship. So they're asking you, on what interval is g of x increasing? So what do you always say when something's increasing? You say, oh, I need to know the derivative. Well, we don't have a formula here necessarily, but we do kind of. We have a formula for g of x, and we want to take the derivative of it. So we are going to take the derivative of the formula, which is 0 to x f of t dt. That's what g of x is, and g prime means take that derivative. Well, the first fundamental theorem of calculus says if you take the derivative of an integral from a constant to x, you're going to just plug in x to this function right here. So you're going to get f of x. Now, why is that important? Well, let's look back. What is this graph? Well, this graph is the graph of f. Okay, so this graph is f. We've just said that g prime equals f. So basically that means that this graph is the derivative. So that's important. If I want to know when g is increasing, I want to know when its derivative is positive. Well, its derivative is just f of x. So when is this graph, which is f of x, this graph is f of x, when is it positive? Well, it's positive from 0 to 3. So our answer would just be, on what intervals is it increasing? We would say g of x is increasing on, and I'm hoping I can move, I guess I can't move those, so we'll just, I'm going to scoot that a little bit. It's increasing on 0 to 3, and our reason is because g prime of x, which equals f of x, I just established that. This step is super important to write that, is greater than 0. So once I've established that, I've connected them. I've told you that I know that g prime is in fact this graph called f. Well, my answer is it's increasing there because that's positive. Then I've already said that g prime equals f of x, so I don't need to do it again. But I have to think to myself, where does g have a maximum? So how do you know if a function has a maximum? Well, you look for where its derivative changes from positive to negative. Well, its derivative, g's derivative, is in fact this graph right here. So if I look at that, I'm going to say, okay, where does it change from positive to negative? Well, it changes at 3. Now, they ask me for the maximum, not just, it says where does it have one, but I can actually answer the maximum because I found the value at 3, right? I found g of 3, it's 7. So that means that it has a maximum at, okay, so g of x has a, and actually this would be a relative max. I don't like this question. It should say relative maximum value, but it has a relative max at x equals 3 because, again, g prime of x, which equals f of x, already established that, showed the work, changes from positive to negative. And now I've answered the question. In the same way, the only thing that's different about this question is the fact that you have to determine that that graph is the derivative. Then it says sketch a graph of g of x. I'm actually going to skip that. You would essentially just plot those points and connect the dots. I'm going to skip doing that. So let's go to this next part. And we're going to actually skip all of this one. Remember that we're going to do some different things, so we're going to skip all of that. And we're going to move, so just flip the page over and go ahead and move all the way to example 5. Okay, so looking at example 5, this is another question that comes up that's really good to understand, and I'll tell you how I think about it in order to answer it. So they're telling you that shown below, so the colorful graph, is the derivative f of some function called capital F. Okay, so we know this is the derivative. Assume that capital F of negative 3 equals negative 8. Here's the way I like to think of that, because I think it helps me figure out why that matters. So they're telling me f of negative 3 equals negative 8. This function up here is its derivative. That means it's like them telling you, if I took all the area and I added it all the way up to negative 3, my answer would be negative 8. Okay, so it's like I've already added all of that up and I'm telling you that's negative 8. Okay, so now they want me to do what is f of 2. Well, to find f of 2, I'm going to add up the areas. But I already know that to here, the answer is -8. So I only need to add up the rest of this. I need to know, what does this equal? Because I already know that to get to -3, it's -8. And now I need the rest of it from -3 to 2 in order to get all of f of 2. So that's how I look at it. So it's going to be -8 that we already know, plus the values that they've given you there, which is 10 plus 26. And both of those are above the x-axis, so they will be positive. And so this answer is going to be 28. Okay? Now we want to know, what is f of 6? So now they're asking, what is it if you add all the way over here to 6? Okay? Well, I already know the answer for part of the way. I already know the answer to here is 28. So part of my answer is 28 plus. Okay? Then I have to just take the areas that I'm given. Well, this one's underneath, so it's negative. So we're going to do plus -8. And then this one's above, so positive, plus 14. So my answer ends up being 34. Then we want to do f of -5. Now, this is a really good question because we have to think about this for a minute. So -5 is back here. Okay? So we have to think about what we're doing. And it's not that hard if you'll think about what I said about f of -3 being all of this added up. So if I go from wherever the function started, I come all the way over here and I add, I get -8. I want to just go, instead of all the way, I just want to know what's the answer from here to here. Well, -8's already included some stuff that I've counted in, and my area ended up being -8. So this little extra part right here has been added in to get -8. So I need to subtract it to get just this part adding up to here. We've done that lots of times with functions and things like that. Same idea. Okay, so I just need that little part to be subtracted. Okay, so I know it's -8 if I go too far. That was all the way up. I'll even just use the same color here. So this to -3 was -8. So I had too much. I went past it, right? So I need to subtract this distance right here. So that's -18 because I got the number here. And then that will give me the answer, which will be -26. So you're going to take your initial value, which is f of -13 equals -8, and you're going to subtract that area to the left of it because we're going backwards. But hopefully, and rewind it if that didn't make sense, and really look at it again. This needs to sort of make sense to you so you can apply this in other situations. When they tell me f of -3 is -8, they're saying all the way added to here from way back wherever somewhere is -8. If I want to find f of -5, okay, that's to the left of that. So I've gone past it when I've added up a bunch of numbers. So I added in 18 to get -8 for this entire thing. So therefore I have to subtract 18 to get back to where I would be just at -5. Okay, so it'll make more sense the more we do things. Okay, so now let's look at D. So D says, since the area under F is positive from -3 to -1. So if we look here from -3 to -1, we're talking about right here. And we know the area is positive here. Okay, it's all above the x-axis. So if we know that the area for under little f is positive on that interval, then it means that we must know that the graph of capital F must be increasing. Okay, because little f is its derivative, and its derivative, that accumulated function, is all positive. So therefore f must be increasing. Now, if I look at the area underneath, so you can see the graph at the same time. So then they're saying, since the area underneath F, if we're in that interval -3 to 1, increases at an accumulating rate. So it's getting more area as I go from left to right. It just keeps adding more and more area. So it is increasing. It is accumulating at an increasing rate. Then that means that we must know that F is concave up, because that accumulation is positive. So its derivative, so to speak, would be positive. If I go from -1 to 2, it is increasing from -1 to 2. So I have to erase some of this so we can see this better. If I look from -1 to 2, I see that the function is positive, but it is the accumulation of area is at a decreasing rate, okay? So the area under F on 1 to 2 accumulates at a decreasing rate, okay? So the area is going down. So F must be concave down on this interval, okay? Because the accumulation, it's still accumulating, but it's doing it at a decreasing rate. That would mean its derivative would be negative, so it's concave down. Now again, I'm not going to graph that graph for that, okay? And I'm not going to do anything else on this chapter. So this is it for this video, and then you'll have another part of a video to do for section 6.